I think that experimentation is the name of the game. We're all scientists here. It would be amazing to try some really fantastical products. If I can be the Willy Wonka of algae, I will have done my job correctly.
Hi, Carl. How are you doing?
Good. Hey, Erum, how you doing?
I'm doing fine. It's getting warmer out there. Spring is in the air.
Yeah, but we just had snow in New York City yesterday, about an inch, and it was on the ground for a beautiful few hours.
It was really nice. My son goes, "Oh, snowflake." He was like naturally drawn to it. Again, he's 2 years old, but I didn't let him go in it just because like the snow in the streets of Brooklyn, I saw a lot of yellow snow. So I was like,
Yeah, dogs.
He doesn't know that yet.
I always say it's beautiful for the first hour or two, and then the dogs have at it. And then if it goes too many days, it starts to get gray and grimy and gross. But it is always beautiful. And it's good that we finally had some snow because we hadn't really had any.
Yeah, that's a treat. But in other news, did you see in the news about the FBI saying that the origin of COVID is likely to be a lab leak from China?
I did see the news. I only saw the headline, so I don't really have a comment on it. That's a complicated story. And I think it's interesting that's the FBI's take on it, especially given all the scientists who previously had said, no, it's not a lab leak. How do scientists know versus the FBI?
I just read like a couple of pieces on it. I read the BBC. I think it's not biased, but I don't know. I like that it's international. But one of the things I was thinking is it could have been a good opportunity to present science more, right? It's like, what is the biology of the COVID virus? How can you tell the difference between a virus that comes out of a lab versus a virus that naturally jumps from an animal to a human? What does that look like? So that people could be a little bit more informed rather than just all the terms that are just thrown out there and people maybe assume what they are or they glaze over it. So when it comes to talking about viruses and pandemics, I think even throughout the whole COVID pandemic, there's an opportunity to talk about the science in a way that it could be understood by people that have some basic knowledge of science. And I hope that starts happening more. And maybe if anyone has a source that does present science in a good way when it comes to what's in the news, I'd love to know what that is.
Yeah, we do have an upcoming podcast where we'll be talking to Natalie Kudell about educating younger students on synthetic biology. We talk about bioilliteracy. Science literacy is very low, and people think that they understand it, and they go through all these sources. And unfortunately, the algorithms do favor the more extreme points of view. And after a while, they start feeding you the kinds of things that you look at. So you do get biased very easily. But yeah, I would love to know more about this and what are great sources that people use to talk about science in a way that's very accessible. So today I'm excited about this podcast because we're going to be talking about biomanufacturing, which is really the use of biology to produce things. I always say that it's most simplest. Biomanufacturing is just fermentation, but it's not. Fermentation is one form of biomanufacturing. So if you think about the way that beer is produced at a big facility like Budweiser, where they're producing 10,000 cans a minute, they are fermenting at a very large scale. However, in the biotech industry, people ferment at a much smaller scale, but fermentation is only one way of biomanufacturing.
And there's a company that just popped up in the news. I think you know more about it than I do. It's called Future Fields. What exactly do they do and why were they in the news?
So Future Fields was in the news because they just got 11 million funding. And what they do is they use fruit flies, so insects, as a factory, basically. They infect the fruit flies a certain way and get the fruit fly larva to produce a recombinant protein. And those proteins are important for cultivated meat, therapeutics, vaccines, and there are challenges to producing those molecules and many others in fermentation. They're not the only company using insects. I had a conversation with a company called Cocoon Biosciences that is based in Bilbao, Spain, that is also using insects as a bioreactor.
Yeah, when you're talking about fruit flies working in manufacturing, I'm thinking of little fruit flies with construction gear on, working the assembly line. That's not what we're talking about.
Yeah, no, that's not what we're talking about. I don't know if this is what happens with Future Fields, but I bet the flies don't even develop. They probably just use the larva through a certain growth stage. I know that's the case with Cocoon Biosciences, and they're using a very specific kind of moth. I don't remember what it is. We can put it in the notes. But so today we're talking about algae, and we're talking to Elliot Roth of Spira, which is a really interesting company. I'm really looking forward to this conversation.
Yeah, how do you know Elliot?
I met Elliot many years ago at a Symbio Beta, and we've stayed in touch with each other. He's an interesting guy. He has a big interest in space, and he started Spira many years ago, probably 5 or 6 years ago. And I'm looking forward to having him tell us how he's using algae as a biomanufacturing tool. I sat in once on a pretty much all day or half day session of different companies that use algae. They were from all over the world, and was really impressed by what you could do with algae. It's a really interesting organism. These guys are using microalgae. Our hope is in the future we'll have Checker Spot, which is a company that creates polyurethane using a microalgae. Biofuels were produced using microalgae. So there's a lot being done with this. And many people take spirulina as a nutritional supplement.
Yeah, I got the spirulina powder because I know about all the antioxidants, and I was like, okay, I'll have this. And I just try to make an energy drink. So I put like ginger, honey, lemon, spirulina, maybe cayenne, maybe, apple cider vinegar. It really depends. I make a batch of it and it's like a concentrate, and then just take a shot of it.
Wow.
So, but I think a lot of people are becoming more familiar with algae because I've been seeing a lot of ads on Facebook or Instagram where like I've seen like a kelp burger being advertised. And of course, the people in the ad are like, oh, this is so delicious, blah, blah, blah. And I'm like, I don't know. But
I want to try it.
I want to try it.
I would definitely try it.
And I saw, what was it, a kelp pickles? So, and it looked like a very big pickle. And in the ad, they crunched like the Clausen crunch. And I was like, that looks like a pickle, but it's kelp. So there's a lot coming online in terms of food, but I'm really excited to learn more about what Elliot's doing and how he thinks about the algae market.
All right, well, let's get started. Let's bring Elliot on the pod. Okay, Elliot, we're super excited to have you. Thanks for joining us today. We were hoping you could give us a lot of information about algae and why algae is a super tool and how you started Spira and what are you guys trying to do. And I will say that at some point, I want to ask you about performance characteristics of your dye, because I mentioned it to my wife, Kristen, this morning in the car. And she was like, that sounds great, but how does it perform? Is it going to wash out? Is it going to make all my other clothes blue? She started asking those kinds of questions. So we'll get into it. Why don't we start talking about Spira? Like, what was the inspiration behind Spira? How did you get started? And what does the company do?
So the genesis of Spira began when looking at the supply chain and realizing how messed up everything is. The world's kind of on fire, and it is because we sort of made it that way. And so the main genesis of Spira was trying to produce basic level of nutrition I needed to survive. And so I think I talked to you about this before, Karl, and the story is back in 2016, I built a garage DIY bio lab with a couple of friends, and I was doing some consulting work for clients that never paid me. And so my overbearing Jewish mother was like, hey, move in to my basement. And I said, no, I can probably figure it out. Like some sort of enterprising 22-year-old, I decided to use the laboratory to try to grow my basic nutrition. And I'm a big space geek and looked into what NASA was doing to feed astronauts, and they were growing algae. And I thought, it's not killing astronauts, probably not going to kill me. And so I started growing and eating spirulina in these aquarium tanks I got from friends. And I would take big scoops out, and I lived on a diet of spirulina and then whatever food waste I could find for a couple of months. And that got the attention of IndieBio because they realized that I didn't even need to be ramen profitable. I could just be algae profitable and survive on my own supply. The genesis of Spira was about meeting people's basic needs where they are. And so producing local supply chains in which we can manufacture and produce the basic raw materials that our economy relies on. It's gone through a number of iterations and transformations since then, but the underlying theme has always been replacing some of these extractive industries with some method of biomanufacturing that's much more carbon negative using genetically engineered algae. And so now we work with a network of about 83 farms globally to produce over 400 metric tons of algae biomass every single month, which is pretty fun.
Amazing. So what does it look like from a volume point of view to be able to feed yourself? What kind of tanks do you need? How long do you need to grow it for? And how nutritional is it?
When I was getting started, I basically collected all the aquarium tanks of friends who had dead fish, scrubbed it out and everything like that. But in essence, it's just like basic salts, air, water, and some light. and you can grow algae, doubles every single day. It's not as fast growing or as dense growing as something like E. coli, but it's pretty damn close, or we're getting closer to something like that. And what you do is you just take a little filter out. And so it only was about 250 gallons or about 1,000 liters of growing. And I could supply all of my protein needs pretty much indefinitely. Anybody who's watching Last of Us or into apocalyptic zombie films or anything like that, I highly recommend getting an algae starter culture if you're a true prepper out there.
So 250 gallons, that's not like a crazy amount. It seems like it's a couple of bathtubs of algae growing.
Yeah, it's roughly 1 square meter. So think of it as 1 cubic meter was about how much I really needed in order to get by. And I set this up in a garage space that was maybe like 800 square feet, something like that, and put it in a greenhouse, a couple of lights shining on it. And that was what I needed to get by for a few months. When it comes out, when you filter it on out, most people think of algae as this bitter, umami, alkali tasting kind of thing. But fresh spirulina especially has no taste, and it's almost cheesy, nutty, buttery, has an appearance like blended avocado or like green cream cheese, for lack of a better term, whipped cream cheese. So it was pretty pleasant. I would combine it in smoothies or spread it on toast or do other things like that for when I was getting started. That led to the true aha moment of Spira, which was looking at the flavor of algae and realizing that the main barrier for people, including algae as more of a component in supply chains, was taste. And really how humans interact and start adopting new materials is mostly on the food side of things and agricultural side of things when we're talking about biomanufacturing. For us, and in particular, I took my background in synthetic biology, genetics, and started looking at flavor pathways, forming knockouts on bad tasting flavor molecules, and then working towards extracting out pigments as a means of making the leftover protein isolate so much better tasting.
Are you making foods right now or focusing on dyes?
So in particular, I think one of the big challenges, and this is across synthetic biology, across multiple industries, when I was getting started, one of the key lessons was interviewing all of the failed algae companies. And there's a ton out there. And one of the key lessons that I learned from many of these companies is don't focus on commodity level industries, especially if you're coming up with a new technology. So many synthetic biology companies out there are trying to produce mass market commodities and can never compete on price, at least at the start. And so what we started focusing on was high-end pigments, because you really only need a low volume and you can sell them at a higher price and you can start generating it. My company is basically breaking even as a means of selling these pigments right now, as in making money as a synthetic biology company, which is not something that many of them can say.
Smart.
Yeah, and I want to go back to you living on this algae diet for one last question.
Sure.
What did you lose weight? Did you get ripped? What was the effect of eating algae all the time?
This is a sample size of 1, so it's really hard to tell, but I was feeling great. I felt like fully self-actualized. And most of my companies and thesis of business is solving for people's basic needs using simple like DIY biotech. So food, water, shelter, all of that was handled, and I could really on what I wanted to do with my life. And so in particular, when I was eating algae, I was feeling great. I lost a little bit of weight, but to be honest, at the time, I probably could have lost a couple of pounds. But what I'm doing upcoming in the near future is testing out an all algae diet, I think, as a means of adapting to a changing climate. We're going to need to adopt new methods of nutrition. And so I've been undergoing a series of tests initially as a means of starting to shift to an all algae diet that's protein, carbohydrates, lipids, micronutrients, everything. And I'm going to do a supersize me diet of algae in some kind of way.
I think you should be very public about this and do a Brian Johnson blueprint type of experiment where we see the before, the after, you describe your full day in great detail, and
I'll show us
video. Show us videos, get your blood work done, et cetera, et cetera.
Right now I'm getting set up with a full metabolic panel, working on getting my gut microbiome sequence, doing basically all of the prep work and coming up with a standard diet going into it as well, so that I have a standard diet going in, a standard diet going out. And so people can see and respond to the sample size of 1. Granted, I'm not in the necessarily like 50th percentile of people or anything, but at least it's qualitative information. It's something interesting. I want to test my limits and see whether or not we can adapt to this kind of diet, because I think algae sources of nutrition, sources of raw materials are some of the best for the planet. And I love testing different things on myself from various products that we create. I think that it's really important if you're building something that you are your first customer.
Right. Yeah.
Sure.
It could be reproducible too. So other people that
Sure.
might want to do it, maybe they can contribute to that. I think it's going to be very interesting to see what type of algae meals you create. Like you mentioned spirulina, but do you have other algae on the menu?
One of the joys of doing this as a business is that I'm able to test out some weirder types of algae too. We predominantly focus on microalgae and cyanobacteria for work. This is what we work on genetically engineering. So different things like chlorella, chlamydomonas, other species of like nanochloropsis, as an example, spirulina, of course, but expanding into other realms of like seaweeds and macroalgae. So different kinds of kelp and sugar kelp, right? Brown algae, red algae. There's all sorts of different types of algae out there. And so you really can have much more of a holistic diet from these various sources.
So just so we can step back and let listeners know, what actually is algae?
This is like my definition as a rule of thumb. Algae, when people define it as generic, is really any photosynthetic organism that grows in water. And so you'll find algae in ponds, lakes, you'll find it off the coast, you'll find it in any kind of body of water that you end up finding. And in particular, algae as like an umbrella term, you have macroalgae, which is multicellular aquatic species that photosynthesize, things like kelp and other species thereof. And then you have microalgae, which are eukaryotes, and then cyanobacteria, which are prokaryotes. And so that's the segments and definitions of all of those.
And I think, correct me if I'm wrong, I think of algae as being a potentially wonderful biomanufacturing organism because it's got 3 genomes. It's got a mitochondria, it's got its normal nucleic and nuclear genome, and then it's also got chloroplasts.
Yeah, you're doing my job for me, man. Keep going. Tell us more. Yeah, I would say that there's a couple of key tenets and lessons learned from interviewing all these biofuel companies that I think can be applied to synthetic biology, in particular, where I see precision fermentation maybe going off a cliff of some sort eventually.
Elliot mentioned precision fermentation, and precision fermentation is part of biomanufacturing. And the idea is that you're using microbes as factories or mini factories to produce very specific ingredients. There's a study out there that says that precision fermentation could help replace half of livestock agriculture by 2030.
In particular, when you take so much money to produce whatever end product that you're selling. All these companies were trying to produce gasoline or oil in some kind of way. And it cost them $1,000 to produce a gallon, and you sell a gallon for like $5 a gallon of some sort, and you're losing $995 per unit that you sell. That's insanity. And I think a lot of the companies focused on commodity industries are going to reach that cliff and end up going off that cliff and failing because you need to sell something in which you can start generating return or money in some kind of way to start that virtuous cycle. So the way I think companies need to approach these marketplaces, especially to undo the damage of the petrochemical industry, is start with really high-end products and compounds and then come down the cost curve, similar nature to a Tesla Roadster style of approach. So start with something expensive and then come on down the cost curve. Some of the other lessons learned in particular, I talked to a ton of companies that were experiencing trouble in either fermentation processes or growing species in which they didn't have any resistance to contamination. And this is a hidden truth about biotechnology, synthetic biology. A third of whatever is produced is thrown away. And it's tossed because it ends up getting contaminated and you're not able to use the end product. And oftentimes, whenever you're starting a fermentation process, it's a race to the end. You're setting up a fermentation process, you're trying to grow as much as possible, harvest as much as possible before it gets contaminated. And we, in particular, started focusing on its files as a means of resisting contamination inherently. And in particular, there's a category of extremophiles, alkalophiles, that will passively absorb CO2 by their very nature of growing in these alkali ponds.
When Elliot speaks about extremophiles, what he's referring to is organisms that live in extreme environments, whether that's places on the planet that are very hot, ponds that are very salty, or places that are deep and dark at the bottom of the ocean where us humans would die. But there are organisms that live in all of those places, and we know them as extremophiles.
And I think that's another benefit of photosynthesis. Fermentation, for all its benefits, produces a little bit of CO2 whenever you're fermenting something, and photosynthesis absorbs that CO2. So passively, we're already reversing the effects of climate change. It's something better than just sustainable is the way that I think about it. We need to go beyond that. And so the other kind of core tenet and something that we learned is that the main operating cost of many of these synthetic biology companies and anybody who is actively trying to ferment something is dewatering. And dewatering comes in the form of energy costs. You have really tiny things that you have to extract out of wherever media you're growing in. And so you have these big centrifuges, you try to pull everything out, crack open the cells, get whatever you want. And in particular, when we focused in on filamentous organisms, that helps reduce most of the operating expense and centers in on labor as the main operating cost. And so we predominantly focus on working with farmers in developing countries to pay them more than a living wage as a means of reducing that OPEX expense and incorporating farmers as core of our process too. And then finally, when you're growing, you want it to be as dirt simple as possible because you're really focused on lowering the overall expense so you can reach those commodity level industries. So we work in mostly open pond systems, covered greenhouses, and that's how we're able to grow so much algae. By some estimates, I think like Capacitor Synonym, and they have this like report through Capacitor Bio, where they're talking about total global fermentation capacity. And they said there's about 25 million liters of fermentation capacity globally that's registered through their platform. And I did a quick back of the envelope calculation. Between our 83 farms that we work with, we have about 250 million liters of algae capacity in terms of growing. So that's like apples and oranges. It's like a little bit different in terms of densities and yields. But I really think that algae has a major role to play when it comes to production of biomanufactured compounds and chemicals.
There's so much to unpack in your answer. I would start with this idea of biomanufacturing and fermentation capacity, because there's been a lot of talk in the industry that we don't have enough fermentation capacity, which is probably true, and we need more of it. You're talking about algae for biomanufacturing, and we've seen just in the news in the last couple of days, a couple of that are related to using insects as biomanufacturing systems. And then there's cell-free. So there is a lot of alternatives. And I think it also really, at the end of the day, is going to depend on what the molecule is that you're biomanufacturing, because
exactly.
In many cases, it doesn't make sense to do fermentation. And we can come back to this whole contamination issue, which I think we should talk about, because this is very related to why extremophiles are of interest. But at the end of the day, it's really going to come down to, hey, we've got this molecule, we want to put it in a beauty product. What is the best way for us to manufacture this at scale? Maybe it's an insect, maybe it's algae, maybe it is fermentation, but the downstream processing that is associated with fermentation, like you say, is a huge cost. And I think a lot of people don't realize that.
The bioprocess engineers, fermentation engineers, and anybody involved in biomanufacturing that I'm talking to, we have this U-shaped curve right now. And at the high end, you have different things like pharmaceuticals. And synthetic biology, a lot of the techniques that we have are derived from pharmaceutical engineering and manufacturing and biopharma, right? And so at the end of the day, what you're doing is you're extracting one particular compound from the entire organism and tossing the rest of it. And that works really well for insulin. That works really well for drugs. And in particular, you can do small batch, low volume, and be really effective at that. But when you get to larger scale and commodity level products like edible proteins, as an example, that's when you start coming up against this price barrier where you're going to need thousands and thousands of these small scale fermenters that are like 20 or 30,000 liters maximum. And in doing that, then that's a huge CapEx investment that we don't currently have the capacity for. And in addition, you need sugar to feed that anyway. So already it's relying on photosynthesis as its fundamental base input. So why not just go a step lower and work with photosynthetic organisms? And in particular, for me, it just makes sense to work with, from a first principles perspective, the basic photosynthetic organism, cyanobacteria.
Cyanobacteria are a type of bacteria that get their energy from photosynthesis. The name cyanobacteria comes from the color, and cyanobacteria are known for being some of the first organisms on the planet, and they actually help build the atmosphere that we humans breathe easily. There was no atmosphere on this planet before the bacteria were here, and the cyanobacteria and the extremophiles that evolved are the ones that created our atmosphere.
That's been our approach all along. It's not like the high-end platforms like insect biomanufacturing or anything in biopharmaceuticals. That's really well suited to fermentation and fermentation processes. Anything that's like milligram or gram scale that you're looking for. When you're starting to get into kilos or metric tons, that's where algae fits really well, and especially more complex proteins and protein-based manufacturing. particularly because, like you said, Carl, there's 3 chambers in which you can do different interactions in different kind of protein construction. And then lastly, on the far end of the scale, when you're thinking about like ethylene synthesis or anything where it's like enzyme-enabled catalysis, that's where we start getting like solugen and cell-free systems, you know? So that's more basic molecules where it could potentially be better than just basic chemistry. And it's stuff that could improve upon what currently exists. But we're not playing in the basic molecules. We're not playing in the high-end molecules. We're playing in those more larger volumes, but starting at the high end of those larger volumes, specialty chemicals, naphtha replacement, stuff like that.
Enzyme-enabled catalysis is a bit complicated and requires us to unpack a little bit. First of all, you need to know that when we talk about enzymes, what we're talking about is molecular machines. These are proteins that catalyze chemical reactions in cells, though not necessarily, because these days you can pull out those enzymes and find them in things like laundry detergent, and they enable you to clean your clothes without using hot water. But when we talk about enzyme-enabled catalysis, what we're talking about is chemical reactions that are enabled with these enzymes or these mini molecular machines.
I had sat in on an algae seminar many years ago, and I think it was like one algae company after another, and I was just so inspired and blown away. Do you know of any company that uses like the multiple genomes to produce complex molecules? So maybe the initial molecule is produced in the mitochondria of the algae, but then it gets some additional work done in the chloroplast, or is there anybody doing that kind of engineering yet?
One of my compatriots in IndieBio was a company called Microsymbiotics, and they were producing vaccines in Chlamydomonas and edible vaccines for aquaculture and fish feed. So that was one where I knew they were doing chloroplast engineering and then doing post-chloroplast engineering modifications in the actual cell. That is as close to what I've seen. But in particular, I think that one of my calls to action for just the synthetic biology community is that we're actually really lacking in model organisms and tool sets when it comes to engineering algae. A lot of what my team has had to do over the past couple of years is develop our own tool sets and develop our own pipelines for engineering this category of organisms. So we mainly play with Oscillatoria species and cyanobacteria more than anything else. And in doing so, it's taken a long time just to do things like characterizing a genome or figuring out exactly how to go about engineering these cells when there's no available protocols. Like something that we have in the industry is we have a bit of stasis and sunk cost fallacy going on with E. coli and yeast and Pichia and B sub and lactobacillus. Those are common strains that have always been used and have thousands and thousands of scientist hours poured into them. And so I think when we're considering other non-model organisms, it's really key to invest in those tool sets and those tools. One of my calls to action in this podcast is if anybody has an interest in developing tool sets for non-model organisms, particularly for algal species, that would be amazing.
We have someone for you. There's a company that we work with who will have Henry on our podcast. It's called Cultivarium. And so they're developing like tool sets for non-model organisms, amongst many things. And when we have Henry on, he will explain Cultivarium. We'll dig deep into that. But to bring it back to Spira, so right now you're developed some pigments with algae, with spirulina, correct? So describe these pigments and who's buying them? Like, how are they being used?
We got started selling pigments about 1.5 years ago. We've sold now over $350,000 worth of pigments. We have sold to companies in food, done pilots with companies like Molson Coors, Colgate. We've done pilots with and sent out samples to Kellogg's, BMW. So we mainly started in food in particular as our main focus. We started moving into more cosmetics more recently, especially color cosmetics. And then eventually, I guess we'll come around to textiles. It has been on the basis of a couple of different deciding factors too. So in food, there is a huge wave of change when it comes to replacing artificial colors, particularly in the United States. Many companies have publicly declared by 2025, they want all artificial colors phased out completely. And so what we're doing is we're stabilizing the algae pigments that go into the usage of these food, cosmetic, and textile formulations, making them temperature resistant. So at temperatures in excess of 70 degrees Celsius, and then pH is roughly like 1 to 2, 2 to 3, thereabouts, and therefore translating into those pigments being color fast as well. So they'll be UV stable, temperature stable, pH stable. And we started out with blue, particularly because blue is really hard to find in nature. And it's also a very complex protein. It's something that was unique that we could really handle in spirulina. It produces up to 20% of its biomass, if not more, if you enhance it in different ways. As the pigment itself, I like working with these species as opposed to trying to like jury rig some sort of metabolic pathway into something that doesn't particularly like it. So we started out with blue. Phycoerythrin is our next pigment that we're working on engineering. And then we've started releasing other varieties like yellow. We have some additional colors coming on out. We have a green now, we have orange, we're going to have another red. I'm actively doing some work on sourcing and engineering a purple currently. So just trying to get the full range of pigments, colors from algae. And in particular, they're already there. It's much more of an enhancement upon the existing photosynthetic spectra.
So you mentioned the food dye, and you said that there's an effort to phase out artificial food dyes. Why? What's wrong with artificial food dyes? Why should people be concerned by them?
Most artificial food dyes currently are produced using coal tar or leftover oil gunk at the bottom of the barrel. So that kind of rainbow shimmer, the iridescent shine that you see in gasoline, that's what we're eating anytime we eat something artificially dyed. So if you eat something that's like a blue raspberry Jolly Rancher, or if you're eating something that's red velvet cake or anything like that, all of that comes from leftover oil scum. And in particular, yeah. So
Sounds
in particular,
appetizing.
I just bought
here-
all this blue food dye for my son's birthday and made
There you
frosting. And now I'm like, I just poisoned all these 2-year-olds.
Let me know your address. Like, we're shipping out samples now. You
Thank
don't
you.
have to use artificial dyes. In particular, there's just as good alternatives when it comes to algae-based dyes or natural dyes. I think one of the challenges that natural dyes face, and part of the reason why we're engineering all of our pigments, is because they're not stable in high temperatures. So if you bake it, or if you end up like mixing it into Gatorade, as an example, most people pick their beverages and their Gatorade on the basis of color, not on the basis of flavor. You're like, I love the red, or I love the blue it is. So you don't particularly know it's like Arctic Blast or whatever it is. You pick things visually, and you are marketed to and resonate with food on a visual basis. It's about 50% of a deciding factor when it comes to buying. And then once you buy it, it's all flavor based, it's all like experiential based. And we produce these dyes without organoleptic problems or anything like that, meaning tiny amounts of the dye. It's really one of the last ingredients in the label, but it's in practically everything. Like artificial dye is in practically everything: blue 1, blue 2, red 40, yellow 5. Where it says lake, that means that it's combined with some sort of like aluminum and lacquered on top. These are the things that we're eating and consuming, and it's really troublesome and problematic. So food was the main focus first.
So no one wants to eat oil scum, but like, have you heard of any health effects, consumption over time? Has there been any research that came across your desk about this?
The FDA has reissued a number of recalls on some of these coal tar dyes previously, like orange in particular was a big issue. They are more or less carcinogens. There's longitudinal studies done on many of these dyes and pigments that show some indication of attention deficit disorder as well, or other potential neurological effects. In particular, one of the challenges, particularly with blue dye, is that it's one of the only compounds that we consume that crosses the blood-brain barrier. We don't really know exactly what happens, but most of these dyes subsist and persist in the body in various capacities. And so it's somewhat concerning that we're not only consuming these oil and petroleum-based products, but that they end up having a longitudinal effect, and they don't degrade in the environment either. And so whenever we're end up producing food products or cosmetic products, textile products, we're dyeing using these artificial dyes, and then they wash away into the environment and bioaccumulate in other organisms too.
When you've gone out to talk to companies about using algae dyes, especially in food products, what's their response? What kind of reaction do you get?
Most of the time, there's 3 performance questions whenever a company wants to engage with a small startup. When you think of a company like McDonald's as an example, their exposure is 67 million people every day. So whenever you're considering these large companies and adopting new technologies, they are taking a big risk. And so you have to have a plan of approach on how you're going to focus in on a pilot test or some sort of example or some sort of small community as a means of proving out whatever the technology is. So in particular, what we focus on is actually working with small brands and companies and then using those as case studies to pitch larger clients. So these are different hair, nail polish brands, working on hair dye, working on like eyeshadow or lipstick or anything like that, working on different beverage brands, candy, confectionery, different food products of some sort. And so we work with these smaller companies. It's easier to reach the decision makers. It's easier to do a pilot test. They're already trying to do new product development and replace artificial colors. So we can work with them from the start. And then we take that as a case study and pitch a larger company. So I can go to PepsiCo and I can show them, hey, this is what we did with a sports drink company, or this is what we did with a juice company, or this is what we did in terms of some sort of tortilla based or anything like with a baked good in terms of Frito-Lay as an example, right? And so in doing that, it just becomes a much easier approach for these larger companies to adopt something that could be considered risky. That's number one. The question is risk and risk versus reward. They're already suffering what I call death from a thousand cuts, where their market share is being eaten away by a lot of these smaller brands. So if they see a smaller brand doing it and the smaller brand is really successful, they'll adopt it by all means. The second thing is then, do you have the scale? And in particular, that's why my team is really focused on building this massive farming network, because we need to be able to reach the scale with synthetic biology. Otherwise, they're never going to engage with us. And then that leads to the third question, which is a question of price. And one of the fallacies that synthetic biology companies have is that you have to vertically integrate. And I think you don't have to vertically integrate so long as that CapEx investment has already been spent on the infrastructure that's already there. And so in particular, by leveraging pre-existing infrastructure, what that means is that we can lower the overall price and get to price parity with petrochemical-based compounds, enabling these companies to actively sell on a sustainability basis and communicate this sustainable supply chain, climate-friendly goals, and all of that.
You had mentioned that you guys have about 250 million liters of capacity. Do you happen to know what global capacity for algae is? How many millions or billions of liters of algae are being grown?
We've tapped as many farms as we could find. So in particular, the only farms that we don't have in our network, we mainly work with smaller farms more than anything else. The only farms that we don't have in our network are some of the bigger players. And those are farms that you'll find in China or India that are pretty massive, or the US-based farms, what DIC owns, Earthrise, so one of the companies, or Cyanotech in Hawaii. And those farms, they're already focused on selling algae as a supplement. And I think it's only a matter of time before we actively engage with them as partners as well. It's much more convincing them that there is a significant demand and something better than what they're already doing. Pre-established and entrenched companies, they're a little bit slower and they need to see some proofs and pilots from the algae farms we're already working with too. So the key is when you're selling a product, you start really high end and then work your way down, low volume. The key with production is you start with much smaller producers and much smaller proof points as a means of building up your foundation to larger suppliers and larger purchasers.
So do you see a future where companies come to you for their biomanufacturing to produce algae?
That's actually what we're trying to launch with our seed round. We've already gone and done most of the supply chain when it comes to engineering our blue pigment, and therefore going from an engineered biomass being produced at a farm and then all the way through refining and processing into a sellable material. And so that entire pipeline of production we've done for less than $1 million now, and we've brought that to scale in some kind of way. And so we're raising our seed round with specific focus of trying to open up our capacity to other companies and have them have an alternative to having to put steel in the ground or fermentation, and using these different organisms that are carbon negative and potentially able to engineer proteins at scale.
Now we're talking about algae that you are farming, so it's very controlled. Have you looked at wild algae or collected algae in the wild and used that? Sometimes when people hear algae, they think of algae blooms, and I'm sure like pervasive. So what's going on with wild algae?
There's significant problems when it comes to different kinds of algae blooms off the coast of different areas. Collecting those algae blooms is something I've seen other companies end up doing. So there was a company called Algix that ended up producing algae as a plastic material that they go into shoe foams through one of their brand's Bloom Materials. And that ends up becoming Kanye West Yeezy foam runners or turning into really high-end Adidas or Nike shoes. And that's amazing. And I think that companies like that what they've done is they've licensed their tech to come, and AECOM is paid by local governments to come and suck up algae from various ponds in terms of algae blooms. I think the problem of treating algal blooms and wastewater runoff actually stems from a fertilizer problem in the first place. And that fertilizer and overabundance of fertilizer is mostly from like Haber-Bosch issues. And so you trail it all the way back. It's mostly how we're applying fertilizer to crops. And I think that's its own problem. And so I try to go at the root of different issues as opposed to potentially treating the symptoms. But like sargassum, the overabundance of sargassum washing up on the coast of places like Florida and Mexico, that's mainly due to improper wastewater treatment prior to releasing that water into the ocean. And I would love to use those kind of materials. There's a couple of people who are actively working to try to do hydrothermal liquefaction on sargassum and then use that material in various ways. For us, that's not really at play right now. I think one of the key technologies that we've worked on is refining algae into various components. And we have like a multi-use technology there. I would love to apply that in the future, but that's probably way further on down the line, like a Series A, Series B level.
What are other companies doing with algae, especially on the synthetic biology side? Like you mentioned biofuels. Many people don't know that algae were being engineered in the early 2000s to produce oil, which didn't turn out because oil prices fell. But what are other companies today doing with algae?
Solazyme was one of the leaders there, where they had raised over $1 billion to produce algae oils. You see some people still carrying the torch of algae oils and algae-derived materials. And Solazyme then became TerraVia, and TerraVia started producing algae oil and algae protein for the food market. And then that was bought by Corbion, which I think still produces some of that algae oil and algae protein. But some of the original team of Solazyme ended up founding Checkerspot, which just raised a big Series B. And
55 million,
yeah, it's pretty amazing to see the kind of designer materials that they can produce. As far as I know, they're using some sort of fatty algal species, like a Schizachytrium that's fermented in some kind of way and then turned into polyurethane. I think that focusing on those kind of lower end materials is somewhat challenging, meaning that it's going to be really challenging to reach any sort of scale or cost comparability, but you can get higher performance out of those materials as well. So it's a balancing act there. I oftentimes describe the production of harmful compounds like polyurethanes are pretty challenging in terms of environmental sustainability. And so production of those is like slavery with a bunch of extras, a la Rick and Morty, meaning you're just going about producing that in a much more complicated way to produce a somewhat challenging material environmentally anyways. But they're doing it in a really interesting and amazing way. I think I'm really fascinated with Triton. They've been around for a long time as well in producing food ingredients. They got Chlamydomonas approved as a protein ingredient. I think that's also a somewhat challenging species to go about scaling up and fermenting Chlamydomonas at scale, but best of luck to them. Companies like Breville, which are doing edible protein, Plantable, which is doing duckweed. You have a number of companies starting to investigate algae. Lumen Biosciences is fascinating. They're doing algae biologics and biopharmaceuticals. Then you have some of the other companies. Semvita is doing algae for CO2 capture and conversion. You have other companies like Provectus Algae in Australia that is working on a microalgae biofoundry of some sort. And then, of course, there's all the other companies that are trying to produce spirulina in various ways for food or colorants or other things like that. Part of my motivation is to help other algae companies get off the ground as well. And so I'm constantly a mentor or advisor, different algae teams in whatever way I can, because I think that one of the big challenges that I see in any early industry is when we hold information close to our chest. And to me, it's really important to share far and wide all the different lessons that we're learning and be very open and responsive and transparent to what we're doing.
And so for our podcast listeners, you can't see Elliot. His hair is dyed green. And so I'm curious about the dye because you pointed at it when you were talking about your algae products. How did you dye it? How long have you had the green? How has it performed over time? These are the kinds of questions my wife was asking.
I was thinking the same thing, Karl.
I played around with different kind of algae hair dyes for a long time and have messed around around in various ways. I think one of the worst experiments that I had was using sodium thioester or like perm kits as a means of breaking down my hair, hoping that would go into the root structure of the keratin and be able to get into the overall keratin sheath. But I eventually started working on first a bleach method and then an overlay of different kind of like gluten binders, some other elements of peroxide solution and some other things like that. But I caution anybody who's working on trying to dye your own hair. There are many caustic chemicals that go into hair dyes. And so be very careful prior to trying to dye your own hair. So what I did was I did a combination of algae as well as standard kind of hair dye formulation. And so it was like a light blue that I then darkened with our algal pigment, so Spira blue, that I laid over top. And it was really a brilliant blue that lasted a couple of washes, probably 2 or 3 washes, and then it started wearing away. And so it faded from that really deep blue to more of a lighter blue and now green. And so I don't mind the green right now, but I think what I'm going to do coming on up is actually experiment with our new red dye as a means of dyeing my hair and seeing what happens.
So the green in your hair right now is actually faded blue, or did you? Oh,
A
wow.
little bit of faded blue and denatured algal pigment.
Okay, yeah, because it looks vibrant. I like it.
It works.
Yeah, so I would just say 2 things to our listeners. So dyeing hair is, as Elliot pointed out, is a very caustic process. And the way I understand it, there's people who know this way better than I do. You basically use bleach to strip out the melanin that colors your hair. And then you, at the same time, what you're doing is you're loosening the cuticle, which is the outer layer of your hair, so that you can get the dye inside. There's a couple of people that we want you to talk to on the hair dye side, since we do have some really good friends in that side of the world, biotech companies disguised as hair care companies, and a couple of people who are working on specifically on coming up with more environmentally friendly, more biology friendly ways of dyeing hair.
I think that dyeing hair is the same as dyeing silk or wool or a lot of other fabrics that we end up using. So this is my secret way of experimenting with various fabric dyes as well. And fabric dyeing process is a hugely caustic, corrosive process as well. And so if I can find more eco-friendly, sustainable ways of going about doing that, my team constantly experiments with food companies, cosmetic companies, textile companies. We have some of them come into our lab here in Culver City in Los Angeles. And so open invite to anybody who wants to try stuff out. Feel free to contact me. More than willing to try stuff. I think that experimentation is the name of the game. We're all scientists here. It would be amazing to try some really fantastical products. If I can be the Willy Wonka of algae, I will have done my job correctly.
And correct me if I'm wrong, but the guys at Living Ink, they also use algae to produce a black dye, right?
Scott Fulbright and his team at Living Ink are phenomenal people. We've been really trying to work hard with them to get inputs into their ink formulation process. They mainly use some kind of like carbon black derivative that stems from algae. And in particular, we've been working to supply them with CMY out of the CMYK that could potentially be used as inks. But yeah, they're doing amazing things working to actively replace ink and ink formulations that are all kind of oil-based as well.
Okay, so just two quick comments. When Elliot says CMY, what he's referring to is cyan, magenta, and yellow, which are the 3 colors that you put into a inkjet printer. And I think probably maybe those are the ones you use for fashion printing. And I do know this, Scott would be okay with me telling you this, but I feel like Scott once said to me that the biggest breakthroughs happened when they hired a ink engineer, which I was like, wait, what? There's people who are ink engineers? And he's like, yeah, it's a kind of chemist. And it just ended up helping them out in a really big way. And I know that their products, I somehow got on a mailing list for this company called Volback. They produce very high-end clothing for guys, and they use the Living Ink black ink. It's not the only thing it gets used for. Living inks get used on Patagonia labels, but these
electric motorcycles,
on a lot
they've
of
been used
stuff
all over the place. We ended up collaborating with them for a t-shirt in which we printed these like metal t-shirts that said pond scum on them. And so, yeah, that was really fun. We used recycled water bottles for the t-shirts. And then, yeah, it was just something fun that we did as a team. But I'm really intrigued by these kind of like edge case innovations where they can actually transfer into normal everyday use as well. And I love hiring unconventional people and approaching it in more of biopunk sense too. I think
Right.
that we take ourselves way too seriously. And especially if we're experimenting and doing things like this, it's important to have fun with it.
Absolutely. Yeah. When we open our merch store, we'll talk to you first.
Sure, of course. I'll hook you up.
A couple of things we ask all of our guests is, first of all, like, you are a scientist. It seems like you've been very passionate about the sciences your entire life, or was there like a moment when you're younger that sparked your interest in biology? Or was it?
Yeah, I was always interested in the sciences because I was left alone a lot as a kid while my parents were working, and I would just go wandering around the woods and checking stuff out. And when I went to school, I was really into chemistry more than anything else. But after I set my chemistry high school teacher's lab on fire, she said, go hang out in the bio room. It's a little less flammable. I started hanging out in biology with the objective of learning synthetic biology so I could create a dragon to prove her wrong. So that's been my start in synthetic biology more than anything.
That is so funny. Glenn, I'm sure you've read a lot of books and movies that are related to synthetic biology or biotech in general. Any of your favorites, any recommendations you have for our audience?
I'm a huge fan of different kinds of science fiction. In particular, I think Autonomous, The Wind-Up Girl Chronicles, the Ribofunk is another really good one. All of those are really cool science fiction books. I'm a huge Kurt Vonnegut fan as well. Anything Kurt Vonnegut wrote is phenomenal. Beyond that, I mean, plug for Karl's book. I think that's a really good one. And then, I think there's actually not too many synthetic biology books out there currently, and I think there could be more. And so any of the listeners, if you're interested in writing, I constantly write. I'm more than willing to collaborate and form a writing group with you as well, especially in terms of startups in synthetic biology. There's not too many out there, but What's Your Bio Strategy is a pretty good one.
And you, correct me if I'm wrong, you're a big believer in Venus over Mars.
I'm a huge contrarian. I like using algae as a biomanufacturing platform as opposed to fermentation, and really focused on Venus as over Mars. There's a whole lot of reasons, and probably an entire other podcast that we can get into. But part of the focus on cyanobacteria as well is that I think that cyanobacteria forms the basis of terraforming planets in the first place. And so if we're ever going to set up a base of operations outside of Earth, we need that foundational microbes and organisms that go help support people on other planets.
Hey, Elliot, anything else that we missed that we should have asked you?
Just that if you ever want to connect with us, all of our social media is at Spira Inc., SBIRAINC. You can email us info@spirainc.com. Go to our website, get some pigments. We're shipping out constantly. We send them out every single week. And so if you ever see yourself in need for potentially food coloring for your 2-year-old's birthday, or you want to experiment with some inks, dyes, painting materials, hair dye, formulation, cosmetics, anything like that, please let us know. And then we're working on some fun things coming on up in the future. So keep an eye out for our newsletter to stay up to date on some of the fun things that we're doing.
Excellent. All right. Well, thank you so much, Elliot. We really appreciate you coming on.
Yeah, we'll definitely have you back on when you develop some more products, and we'll put all of that in the show notes as well. All right. Wow. That was a lot to unpack. Elliot, man, he's the algae king, isn't he?
Didn't he say that he has something like 250 million, was it gallons or tons online? Liters?
Yeah.
Yeah, that's amazing. I want to just interject. For those of you who are not in New York City, there is a high school that is on Governor's Island, which is an island in the middle of New York City Harbor. And that high school is focused on oceanography. It's also focused on training kids to be ship pilots and scuba divers. And they have a huge algae room. They've got multiple tanks that are full of different kinds of algae. I've gone there on high school tours. I think I went there on one high school tours. And my youngest son, Felix, has a good friend who went to that high school. They take a boat to get there every day. And apparently it's a really nice school.
Yeah, they do a lot of oyster farming too.
Yeah, the Billion Oyster Project. Exactly.
Yes. Yeah. Oh, that's really cool. This passion rose up inside of him after college, sustaining life, just eating spirulina from people's fish tanks. I loved how he described the flavor profiles of the algae that he was eating. He said cream cheese. And I was like, wait, what?
Yeah.
Cream cheese tasting algae? Sign me up. I'll take some of that.
And I think the other thing that was interesting about what he's doing is most people don't think about food color. And Elliot made it very clear that we respond to food visually as much as we do through our olfactory senses and how it tastes. And I was a little grossed out by the idea that many food dyes are made out of this oil sludge. And then also very optimistic about this use of algae-based color for food. That got me very excited because I had no idea.
Yeah. And I had thought about it, and I should have mentioned this to Elliot, but like I had the spirulina powder, and when I was making frosting for my son's cupcakes, I was like, should I use it? And like, I know it has a fish taste to it. So I'm like, I don't know if it's going to have this fishy aroma in this cupcake. And I'm like, if he eats it and I feed it to his friends, there'll be a big uproar of 2-year-olds being like, ew, what is this fishy tasting cupcake? So I'd ruin like cupcakes for them. And my son will be taunted for the rest of his life being like the stinky cupcake boy. So I couldn't do that. I need to try. Like I mentioned, like he's not giving away samples, but you can get samples through him. And I would like to try it and see what the flavor profile is. If there is any flavor or zero flavor, ideally zero, but it would be cool to try. And also for the other applications that he had mentioned, like hair, that was really cool. I hope that we have online for people to see, so you can see the color of his hair. It was amazing. I liked it.
Yeah. And I also wonder, like that whole conversation about the way the spirulina tastes, it made me wonder, does it taste different if you are doing fresh water versus salt water? What is the taste profile if you change the environment in which it's being grown?
Oh, yeah.
And then also this idea of genetically engineering it for very specific applications makes me very curious in terms of, is it a way that you can change the way it tastes?
Yeah, that's actually a really good point. It's like the whole idea of terroir, like that's also a big thing, obviously in like the wine world, but like in the cultured meat world. If you're growing meat in the lab or in these big bioreactors, they don't really have a terroir. So how do you inject or infuse terroir into cultured meat? So that is, I think, a really good topic, and we'll have to talk to someone from the cultured meat world.
For me, one of the bottom lines about the conversation with Elliot is just this realization that there are multiple ways to use biology to manufacture things. And in our intro, we were talking about future fields. We were talking about fermentation. We've got another friend who's in France who they use plants for biomanufacturing. We have people in the States that use plant cells for biomanufacturing. So there is a lot of alternatives, and that's going to become increasingly important because you can't ferment everything. And some peptides or molecules are very complicated and they just can't be grown in a vat like a beer.
And we talked about cell-free in the last episode when we were talking to Seth, and that's a very big, hot area in this world of biotechnology. And I'm sure that'll also pop up.
Yeah. So speaking of Seth, in our episode on cannabis, that was the fastest climbing episode that we've had.
I wonder why.
Yeah. I mean, it came out of nowhere and quickly made it into the top 5 episodes of Grow Everything. So we're super happy for Seth, and we're happy for the listeners who obviously enjoyed that episode. We've got a lot coming up and are looking forward to sharing more with you, our listeners.
Absolutely. Please stay tuned. Again, we always like to say, share, subscribe, Grow Everything Pod. You can find us there. And we look forward to the next episode.
Talk to you later. Thank you.